All right, so we're talking about horizontal and vertical asymptotes. So if you're going to title your notes and then put today's date at the top, that would be smart. Today's date is the 5th of October. And we're talking about horizontal and vertical asymptotes. And if it isn't enough fun to say asymptote, I also get to say a whole today. So I'll show you that later. All right, let's move on. If you start with this one and you ask, or just ask for the domain on it, the domain is two things. One is, how do I make it crash with having a 0 on the bottom? This doesn't have a denominator. So this one can't crash that way. But this one can have a negative underneath the root. Would you please set this one greater than or equal to 0, and then draw me a number line that shows what numbers would work. That's what the domain is. Okay, so go ahead and do that. X squared minus 16 is greater than or equal to 0. Solve it. Probably can factor it. There are other ways. So is tonight's football game a pink out too? Cool. I hope this is close enough to pink. Get pink across. All right. So you say x squared minus 16 is greater than or equal to 0. Now what do? You solve it. I could just move the 16 over and say x squared is greater than or equal to 16. And take square root of both sides and say x is greater than or equal to 4. That seems really easy, but it's wrong. Yes, because the absolute value of x is what you get when you take the square root of x squared. That gives you two answers. X is greater than or equal to 4, and the other one is x is less than or equal to negative 4. Some of you are probably like, what just happened? Okay, what just happened there was when I took the square root of both sides, do you remember me telling you earlier in the year that brings in this absolute value thing that everybody forgets? Okay. If you weren't here when I was explaining that, I'll explain it to you again on a different, just off to the side. Do you get that x squared equals 9 could be solved with 3? Do you get that there's actually another answer? Negative 3. So when you are taking the square root of both sides, you don't want to just forget that and think there's only one answer. There's actually two answers. All right, so what you really should do is this. Absolute value of x is equal to 3. Pause. Re-recording again. Okay, you'd split this into two parts. X is 3, x is negative 3. But when you're doing a greater than or less than kind, like the one I was just doing here, when I change to x is greater than 4, that's the same as it was. But then I got to change to x is less than or equal to negative 4. When I change that sign, I got to change from positive to negative. Then I got to change this sign. All right, so now how do I do this? I'm making a number line. What are the key points? 4 and negative 4. And then I got to see if do they work or not. It says or equal to, so it works. If I wasn't sure, I could always just take the 4, stick it back in, see if it really works. Is that going to cause a problem? No, it equals 0, and square root of 0 is okay. It's not especially troublesome. 0 is okay. Just don't want 0 on the bottom, on the denominator. Then I test numbers in between, like there's 0 is a great number to test. If I put in 0, do you see what happens? You get a negative under the root, so it won't work. And then I can test numbers like 5 and see what happens. 5 squared is 25. Does that cause my function to crash? 25 minus 16? Oh, that's fine. I don't even care what the answer is as long as it doesn't crash. But it works. And the negative one would also work. So my final answer is from negative infinity to negative 4. And it works at negative 4. Union with 4 to infinity. And beyond. Is there anybody that had that right from the beginning? Ooh, 3/4 of the class. Okay, so let's try another one. Odd and even was I taught you yesterday. If I draw you a picture and I say, here's a function, is it odd or even? What would you say? That one's even. Okay, how about this function? Odd or even? Even. Because it has symmetry across this axis here. Okay, but how about that one? Probably neither. Okay, if I wanted to be sure, I would take a spot like, let's say, this spot right here, and I would go through the origin and see, is there another spot over there that hooks up with? No, there isn't. Just remember, the symmetry for odd ones is through the origin. Okay, so let's show you one that does have odd symmetry. If you had, for instance, that has odd symmetry. Because if I pick a point, let's say right here, go through the origin and to the other side, is there another point waiting for me? Yes, there is. Okay, that's got odd symmetry, so that's odd. Now, back to how do I tell algebraically? Well, you got to know a formula. Can anybody recite the formula to me? The even one. F of negative x is f of x. Very good. The odd one was just like that, except one thing is different. If it's odd rule, it's the exact same, except now you throw in a negative right there. That's the odd rule in. Do you get that both of them need you to figure this out? So whether you test the odd one or the even one, there's no reason to do this again. You already did it when you tested odd. So if you test odd and it's not odd, you already got this answer. Use it again when you're doing the other formula. So let's actually test one. Take that one right there, the one we just did the domain for, and now test it for me and tell me whether it's odd or even or neither. What would you start testing? Even. It's most likely to be even if it's going to be anything. Okay, so is it even or not? So you use your little test. And then you draw a line down the middle. That's how it's a two-column proof. It's the way I like you to do them. Thank you. Now I'm going to put in empty spot where the x is. And what am I going to drop in? Negative x. And then when that gets squared, does it come out positive? Yep. Square root of x squared minus 16. And for f of x, I just put the function right here. That's all I got to do. Copy it down there. So, moral of the story? Is it even? Yes, it's even. Okay. Hard to know because I don't know what that graph looks like, but I do know now that it's got even symmetry. So I know that it's got symmetry going across the y-axis. Okay. Do I even need to test if it's odd then? If it's even, it can't be odd. All right. Let's do this one. This is a review of the rational function. Do you remember this function? It's got asymptotes that go this way and that way. Remember this one? Okay, that's the function 1 over x. It's an important one for you to know. All right. Do you get that this function would have a problem if I put in x equals 0? That's what makes the asymptote line. See, that's what causes this thing to have an asymptote there. I can put any other number for x in. I can put in like -3. I can put in -2. I can put in -1. I get answers. But as soon as I put in 0, there's nothing. It's because there's an asymptote there. All right, so how do you tell where the asymptote lines are? First thing you do is find the domain for it. All real numbers except x cannot be 0. And then whatever crashes your function, that is your vertical asymptote. I like to sometimes call them vertical asymptotes because they're x equals things. And so often kids get that confused. They think that they're y things, but they're not. It's a line that goes like this. And so kids think, oh, that's like the y-axis. It must be a y line. No, that's the line x equals 0. It's easy to goof up in your head. All right. And then the horizontal asymptotes, I sometimes like to call them horizontal asymptotes because those are always y things. And it will be hard for you to remember which one is which. They're y equals things. And the horizontal, just look at this picture. I'm going to get all my writing out here so you can look at the picture. The horizontal asymptotes is the line. Horizontal means I'm going to cross like the horizon. And it's this line that's running right there. Okay? So, again, kids think, oh, that's the x-axis. It must be x equals whatever. The y equals thing. This has a horizontal asymptote at y equals 0. The vertical, again, was the line that went up and down, and that was at x equals 0. And the domain, again, was that x could not be 0. All right, so I'm hoping you're feeling like domain's easy now. And the vertical and horizontal are kind of a new thing, but at least you know what they look like, and you should be able to say, oh, well, there's one there and one there, so it's 0 and 0. But what about if it's like, well, here's one I want you to write down in your notes as your like classic example for today. So if you're studying with a friend and you had to show an example because they didn't take good notes of how you could show if something's got vertical or horizontal asymptotes, here's how you do it. Your first step is to find the domain, because whatever will crash your function, that's an asymptote. Because if the function doesn't work, it's going to cause an asymptote. Or it could cause a hole. Okay, a hole in the function looks like this. You have your function going along like normal, and all of a sudden, oh, at one little spot, it just doesn't work. And then it keeps going from there. You might think, you don't seriously have functions like that. Yes, we do. We have functions that just at one spot won't work, and every other place it works. Okay, I'll show you one. Let's say that you had x plus 1 over x plus 1, x plus 3. You see how there's something on the top and the bottom that cancels? Whenever there's something like that, that creates a hole at the spot wherever it would have caused a 0, which would be like -1. So where x is -1, it would have an empty spot. So that'd become more like this, where there'd be an empty spot right at -1. Empty spot right there. All right, you don't have to be an expert at holes yet. I just wanted to tell you there's two ways that things can not work in a function. If it crashes your function, it's usually an asymptote, but sometimes if there's another one exactly like it on top, then it's a hole. I'll get you that more later. That was just a brief intro, so later you'll be able to understand it better. All right, so all real numbers except x cannot be -2. So far, are you totally with me? All right. Now the vertical asymptotes. Here's another way to remember that verticals are x's. Watch what I do with these. You see my v in vertical? See what I just changed it into? Huh? All right. Whatever works for you to remember it, but that's an x equals thing. The vertical asymptote is x equals something. And remember, they come from the domain. Whatever crashes your function is a vertical asymptote. X equals -2. The horizontals are more complicated. You have to choose whether your function is bigger on bottom, bigger on top, or same on both. And then you pick the right one, whichever it is, and then I'll tell you how those work. All right, first though, I realized last hour that kids were not understanding what bigger on bottom meant. They were saying, oh, like, this is bigger on top. That's not bigger on top. It seems like it's bigger on the top. But what are we talking? We're talking about the degree of it. Do you get that this is degree 1 and this is also degree 1? Therefore, this one is actually same on both. Because the degree is the same on both. The degree is how big is the biggest power. All right, so if you had like this, x squared plus 3x over x, what's that one? Bigger on top, because the degree is bigger on the top. I'll tell you what happens if it's bigger on top later. Right now, I just want you to get how to decide if it's really bigger on top or bigger on the bottom. All right, so what if it was like x to the third over x to the second plus 4x plus 15? Doesn't that seem like it's bigger on the bottom because it's got all that extra junk there, but it's not. What is it? Bigger on top. All right, here's another trick you want to get people. Bigger on bottom, bigger on top, or same on both? Some people say same, and I heard some people say bigger on top. Why? If you want to argue that it was bigger on top, why? Yes. Yes. Then you'd have what? If you FOILed it, you'd have an x squared on top, which makes it bigger on top. Okay? All right, next one. 1 over x. Bigger on top, bigger on bottom, same on both. Would you agree there's a little 1 right here that we can't see? So it's degree 1 on the bottom. And some people are saying, well, see, there's a 1 on the top, so it's degree 1 on the top. Nope. There's no x on the top. That's kind of like, isn't 1 the same as x to the 0? So it's degree 0 on top. It's degree 1 on the bottom, so it's bigger on the bottom. All right, so let's do a couple more. Let's say I had 2x to the third plus 3x over 5. Well, that's pretty clear. Bigger on. As soon as I go like this, though, now what is it? Bigger on bottom. And as soon as I go like this, same on both. Okay, now here's how you decide what to do when you know it's bigger on bottom, bigger on top, same on both. If it's bigger on the bottom, there is a simple answer. Y equals 0 is the asymptote for that. I like to think of it as Bob is a 0. Sounds kind of like a cut down, doesn't it? Take notes. This is really good stuff. Really need it. If you write it down, you'll remember it. I want to leave this open, but lunch is just too loud. All right, so if it's bigger on top, Bob is a 0. My dad's name is Bob. I'm not anti-Bob. It's just the way it works. Okay, next one is bigger on top. What's the rule for bots? There are no bots. You're imagining things. It's no bots. It's kind of like robots. What that means is because you know asymptotes. So if it is bigger on top, there are no asymptotes. And the last one is the same on both. That spells the word sob. And these make you sob because they're so hard. These are the hardest ones. They're not that hard. They are the hardest ones. And for the same on both ones, you need to do a ratio of lead coefficients. I'll show you what that means in a few examples in a minute. Ratio of lead coefficients. Well, this one is what? Bigger on bottom, bigger on top, same on both. Bigger on top. If it's a bot, then what's the answer? There's no bots. So there's none. So my answer for horizontal asymptotes, none. All right, let's do a few more of those. The ones where you have to find bigger on bottom, bigger on top, same on both, those are the hardest ones. So let's do a couple more of those. 2x squared plus 5x over x squared. Bigger on bottom, bigger on top, same on both. Same on both. So if it's same on both, it's a ratio of the lead coefficients. The lead coefficient here is a 1. These are always y equals things. They're the horizontal asymptotes. So what do you think the answer is? Because it's 2 over 1. That's the lead coefficient. That's the lead coefficient. So it's 2 over 1. 2. That means if I graph this, there will be a line at 2. That'll be an asymptote line that it'll never touch. I guarantee it. You can know ahead of time how this graph's going to look. I don't know exactly how it will look. I mean, it might look like this, it might look like that. I don't know, but I know it can never touch the line going across here. All right, question. Yes. Good question. Does this make it any bigger on the top? These are put together, but the plus though. So 2x squared plus 5x squared just makes 7x squared. So it's still going to be an x squared, so it's still going to be same on both. And so then the lead coefficient, when I put these guys together, this is a tricky one I wouldn't do to you, but you did it, so I'm going to, if I make this like you said, then I'm going to make them 7x squared. Then the ratio of the lead coefficients is 7 over 1. Okay, so it would be 7. I wouldn't do one that. All right, let's do another one that's kind of more normal. X over x minus 1. Bigger on bottom, bigger on top, same on both. Same on both. And the ratio of lead coefficients would be 1 over 1, so y equals 1. All right, but I got a curve bolt through it. If I go like this, what's the ratio of the lead coefficient? 1 and -1. So when you divide 1 divided by, there's 1 here, there's 1 there. So 1 divided by -1, you would get, right? So this would be, because it was same on both, it's a ratio. And the ratio is 1 over -1. So y equals -1. So on this graph, if I graph my calculator right now, I'd like you to try one, and this is about the simplest one we have. X over 3 minus x. Now, if you were to type that in, this is a good reminder for the SAT and ACT tests. Kids get this wrong all the time because they type it in the calculator as this. X divided by 3 minus x. And then your calculator thinks it's x divided by 3. And then subtract x. And that's not what you want. You need parentheses there. Otherwise, it won't work right. You type that in and see if there isn't a line at -1 this graph would never touch. Okay, so I'll graph mine quick. X divided by parentheses 3 minus x. X divided by parentheses 3 minus x. End parentheses. Enter. Graph it. All right, now it's hard to see where, like what it's avoiding there, but you can see there's some line going across. There's an asymptote, it's some line going across. The asymptotes aren't actually on your graph. They're like dotted lines, that is imaginary kind of dotted lines you can't see. All right, so I could zoom in a little bit. I'm going to do a zoom box, and I'm going to focus in on the area right between those lines. Kind of just zoom in on from there maybe to there. And that'll maybe be able to help me see better where that asymptote line is. Right. If you have an older calculator, it'll actually draw the asymptote line. The newer calculators, it doesn't. Because technically there's not a line here. That's why they fixed it up. The asymptote lines aren't supposed to be showing. Now, if you wanted to see if there was really a line right there at -1, you could go here and you could make the other graph, the other line, -1. And just see if when I put that in there, that looks like it's going through the graph right there. And look at that, my line's going right through there. See how it looks like it's an asymptote now? So there must be an asymptote at y equals -1. No, on the older calculators you can't. But you just have to think the graph looks kind of like this then. It'll be like, and then it comes back up again and goes like, well, it depends on the graph. These lines that are like this, those asymptote lines, if you put them in at all, make them dotted. Asymptote lines, you use them as dotted. All right, so let's say we had this x cubed over 3x cubed. What's that one? Bigger on bottom, bigger on top, same both. Same on both, and therefore it's sob, and those are the hard ones, and therefore ratio y equals what? 1/3. There'd be a line at y equals 1/3 that would go across on this. All right, then how do you get the x ones again? The y ones are, you ask Bob. Ask Bob why. Okay, but the other one, the x's, you got to do from whatever crashes your function. Is there something that will crash my function? Yes, and that thing makes the asymptote. So what crashes my function? So that thing makes the asymptote. 0. Equals 0. All right, now I think we should do something together off the worksheet. Here it is. Hold the work here, not grading. Made this statement. I know it's frustrating. You do your homework and then sometimes they grade it and sometimes they don't. But you get the point that I wouldn't even really have to grade it. I mean, you've got all the answers. They're all there. What is the reason I even grade it sometimes? I'll just keep you doing it. Really, that's the only reason, because you already got the answers. I mean, I do understand there are some teachers where they never tell the kids the answers to the homework. That's awful. You can't even tell if you did it right. The answers are all there. If you want to know, you can always check. Why do I even grade it? Just to make you do it. Because I know you. I know that if I don't put it in the grade book, you're going to say, well, I guess I don't really need, I got too much stuff to do tonight, and I'm not. So I throw it in the grade book, and it makes you want to do it more. Some of you still don't do it. Because I think you think that it really won't matter much. But it will. It'll lower your grade in this class. Maybe not a ton. It'll make it lower. Most of you want it lower. When it's all said and done, you'll say, what is some homework? I've had better scores in the test. And I also have better score on the homework paper. All right. So this worksheet is longer than it needs to be. You may skip problems 2, 4, and 6. That's not a lot, but it'll help some. All right, so let's do number 1 together right now. Number 1 says x over x minus 1. If I were going to do that problem and I wanted the horizontal and the verticals, the horizontal are the horizontals, and the x ones come from the denominator right here. They tell me what to put here. So do you get that I'm going to say x equals what? 1, because 1 would crash the function, and that creates the asymptote for that. And then the other one is the y. Ask Bob why. Is this bigger on bottom, bigger on top, same on both? This is actually a SOB, same on both. So it's the harder kind. So I find a ratio of that over that, and so what is it? Y equals 1. 1 over 1 is 1. Done. If you actually graphed it, can you picture that there would be an asymptote at 1 this way and 1 that way? So this is how that thing would look. Okay, it would have asymptote lines like that. You aren't asked to graph it. I just want you to understand that that's what's happening here. Finding the lines, the dotted lines, that this function would never touch. Okay, on to number 2. Sorry, you're right. Number 3. Big strong guy in the front row. Would you read me number 3? All right. So the x equals things are coming from the denominator here. So tell me, is there anything that would crash that denominator? 3. So it's x equals 3. It crashes the function, and therefore it makes an asymptote line. And the y? Ask Bob why. Is this bigger on bottom, bigger on top, same on both? Same on both. Be careful. You've seen this one before. So 1 and a negative 1 are the two things you take a ratio of. 1 divided by negative 1 is negative 1. Okay. You feel like you're getting it? All right. Did you guys ever have that talk with your parents about the Easter Bunny? Or about the... Did any of you guys ever... Did any of you guys ever have like a terrible reaction to, oh my gosh, there seriously isn't a Santa Claus? Some kids seriously, some parents, I don't know why they would do this, but like videotape when they tell their child. Yeah, and they put it on YouTube. All right, so your parents never told you, you found out? I found it. Gotcha. Well, you know how I told you that that these asymptote lines are things you never touch? Well, sometimes you do. So, along the same lines as the whole Easter Bunny and the Tooth Fairy and stuff, I want to tell you ahead of time so that somebody else doesn't get to tell you that I lied to you. Okay, because asymptotes, you almost never touch them. There are some weird cases in which you do, and the teacher that made the worksheet made us look at that situation. So let's look at number 8 together for a second. The Greek roots of the word asymptote mean not meeting, since graphs tend to approach but not meet their asymptotes. Which of the followings have graphs that do intersect their horizontal asymptotes? Okay, so well then first of all, we got to figure out what are the asymptotes. So we'll look at A, B, and C, and we got to figure out their asymptotes. Asymptotes are the y equals things, right? The horizontal, the horizontal, the y thing. So we want to find out for A and B and C which ones the y equals thing is what. So is it bigger on bottom, bigger on top, same on both? On A. It's bigger on the bottom, so therefore what's my asymptote then? Y equals 0. In case you're following along at home, the problem for A is x over x squared minus 1. So we're figuring out the horizontal asymptotes, y equals 0, because it's bigger on the bottom. And the rule for bobs is that they are y equals 0. Okay? So then, the question is, will this thing really ever be 0? It says there's an asymptote there, which says that you should never actually touch it. But we wanted to tell you there are some times, and this happens mostly in calculus, where you're graphing one and it'll end up touching the asymptote line that's not supposed to be touching. Okay? If y is 0, do you get y is the same as f of x? If f of x is pretty much y, and I'm pretty much saying that this is pretty much 0. Now think about it for a second. Is there any number I could put in? That's weird. Is there any number I could put into this function that would make it equal 0? There it is. 0. Very good. Because if you put a 0 in, it'll be 0 on top, and do you get that 0 divided by anything would be 0? So this is one of those functions that would touch this, because you can make it equal 0. Now the cheating way to do this is not even really cheating, it's just kind of a pain, would be to graph it and look at it and see if the line actually ever touches y equals 0. Y equals 0 is otherwise known as the x-axis. And if you actually graph this thing and you look at it, it does touch the line y equals 0. But another way to do it is the way I just showed you. So for the next one, for B, first step is, what is the y equals thing? It's bigger on bottom, so 0 again. So can g of x, which is x over x squared plus 1, can that, x squared plus 1, yeah. Can this one equal 0? Can I put a 0 here? Yeah. Because I could make the top part equal to what? 0. If I make the top part 0, the whole thing's going to be a 0, isn't it? Because 0 divided by anything is 0. So I can make that one touch its asymptote. So the first two touch, the third one probably doesn't, just judging by most teachers don't give all examples of ones that work. But try it. Can that one touch its asymptote too? It's bigger on the bottom, and therefore it's y equals 0. And can you make the last one touch? Yeah, you can. So, teacher wanted to break the rules. The teacher normally doesn't do that, but. All right, so on that one, you were trying to find the horizontal asymptotes, and in all these cases, they were always bigger on the bottom, and therefore they always had a y equals 0 asymptote. If you actually look at the graphs of all of them, you'd see that they actually touch the asymptote that they're not supposed to touch. Okay. Moving on. Symmetric with respect to the x-axis. Basically, where they're saying it's got symmetry this way. Now, if it's got symmetry that way, can you tell me something that's wrong with it? It's not a function. Okay. So now you've answered the question about, can this thing be, it says that it's stating that it cannot be a function. Do you agree? If you agree, say what? All right, next thing is talking about continuous. If I'm talking along and out, and that's why the cat hates the dog. Do you feel like there was a gap in my story there? Well, my story wasn't continuous. See, I was talking and then all. So do you understand? That's not continuous. So continuous is just about going along and then having a gap in it. So can a function go along and have a gap in it like this? Yes, it can. It creates a hole. And we talked about that earlier. This one, I'm going to tell you exactly which one this one is. It's 1 over x, where I want it to have a hole at about 3. And so to make a hole at about 3, I just have to go like this. If you were to graph this equation that I just wrote on the board, and by the way, you'd have to have parentheses around the whole bottom whenever you put that in the calculator. The whole top 1 times anything is just itself, so you won't even need the 1. So you wouldn't even need parentheses up there. But anyway, if you graph this, you'd find there'd be an empty spot right there. Because if you stick in 3, Do you get? Oh, that's going to cause a problem. See on the bottom? I got a 0 on the bottom. So don't worry about it too much. I'm just giving you a brief introduction to what holes are. Holes are just a place where when something cancels like this, it creates a hole. There can be an empty spot in a function. That means just right in the middle of, and then it ends. There's a gap. Okay, so it asks you about a few situations, and are there any of these that would have gaps in? Right, so they ask you to pick out which ones would be continuous, as in flowing nicely and not having any gaps, and which of them would be, and then all of a sudden it's over because it's got. All right, and the last thing is about increasing and decreasing. I think you're good at that. So don't forget about the review. The reviews are really helpful for you to be able to do well on the big test we're going to have in about a week and a half that covers everything we've had so far. Okay, we just finished making it. So it's coming. You aren't having, first you're going to have the other test. That one's coming on Wednesday. Then you have some more time, and then we take the other test. Fly. Tried to kill it once. Okay, so you've got not too much time, but you have the rest of the time to work. If you are stuck on any of these, I do like helping you one-on-one. I just don't usually get much time to do it. So feel free to ask. Come on up if you have questions.